Um, Today we're going to look at the second part of the final exam practice. So this is the other part of the unit circle. One of the things to note is that for our second test, when we were talking about the unit circle, I gave you a copy of the unit circle, and that will be replicated on the final exam. So this will be one of the pages of the final exam, and not necessarily the fourth page, but somewhere on the final exam, probably the last page, you will have a unit circle, specifically this unit circle for your reference with this information up at the top. So this will be a given. Keeps you from having to memorize the unit circle. All right. Let's talk about what I care about as far as reading these problems go. So I've told you that cosine of t is equal to -1/2. One of the things that we can do with the unit circle is use the unit circle to help us solve equations. So let us solve some equations. In this case, cosine of t is equal to -1/2. The first thing that we notice is that cosine is negative. And so the first thing that we might want to notice, we don't have to write this down, but we're thinking it. T is in quadrant 2 or quadrant 3. Those are the quadrants where cosine is negative. Oh, that was actually the first question. Never mind. So T must terminate in quadrant 2 or quadrant 3. T is in quadrant 2 or quadrant 3. Cosine is negative in quadrant 2 and quadrant 3. If we think about all students take calculus, cosine is positive in the first and fourth quadrant, so negative in the second and third quadrants. So T must be in quadrant 2 or quadrant 3. Sine of T being positive, this tells us, this is where we need to look at two things. Since sine of T is positive, this is telling us that T is in quadrant 1 or quadrant 2. Since T has to be in 2 or 3, or 1 and 2, T must be in quadrant 2. So this tells us that T is in quadrant 2. So now we want to find the values of sine T and tangent of T. There are a few ways to go about this. First, we could notice that cosine and 1/2, we're talking about a reference angle of pi over 3. And then find the sine or the cosine. Or we can draw a triangle with an adjacent of -1, a hypotenuse of 2, and then solve for the third side. With the Pythagorean theorem. And it would be positive because we are in the second quadrant. This is one of the things that we can do to discover that sine of T is positive √3 over 2. For tangent, we could use the same triangle, but do opposite over adjacent. So opposite is √3. Adjacent is -1. Actually, let's write this properly. -3 divided by -1. Sorry, square root of 3 divided by -1 is just negative square root of 3. So we can build tangent with opposite over hypotenuse, and we can build sine with opposite over hypotenuse and tangent with opposite over adjacent. So that would be using reading cosine of t as adjacent over hypotenuse. This is not the only thing that we could have done to solve this problem. We could also use a Pythagorean identity. So if cosine is -1/2, we could remember that sine squared plus cosine squared is equal to 1. So we could have gone with cosine squared t plus sine squared t is equal to 1. And then put the -1/2 in for the cosine of t. Now we just have to solve for sine. And then take the square root. So sine of t is plus or minus the square root of root of 3/4. The square root of 3 is just the square root of 3. The square root of 4 is 2. And we want negative because sine is positive. So to decide on plus or minus, sine is positive. In this case, since we are using identities already, we can just use an identity for the tangent. So sine of t is square root of 3/2. Cosine of t is -1/2. So tangent of t is negative square root of 3, just like we got before. So here we employed a strategy of using identities. And in the previous version, we used a right triangle. In part C, we want to draw the points on the unit circle corresponding to cosine of t is equal to -1/2, and then label the coordinates of each point. So the cosine of t is the x coordinate. So cosine of t is the x coordinate. So I want to look for where an x with it points with an x coordinate of -1/2. We want to label the coordinates of each point. The x coordinate is cosine and the y coordinate is the sine. So the coordinates up here, x is -1/2. That's for both points. Quadrant 2 is where sine is positive. That's going to be a square root of 3/2. And in the third quadrant, sine is negative. So that's going to be a -√3/2. On the unit circle, the x coordinate is cosine, the y coordinate is sine. We have two angles from 0 to 2 pi. We have two angles that we're looking for in the last part. We have a reference angle. So cosine of t is equal to -1/2. We have a reference angle of pi/3 radians in the second and the third quadrants. So our reference angle is pi/3 radians. And we're going to put this in quadrant 2 and quadrant 3. We're going to put a reference angle of pi/3 in quadrant 2 and quadrant 3. This one we know exactly, and we'll have reference to it on our unit circle. So I've got the point -1/2 √3/2, -1/2 -√3/2. So the pi/3 reference angle is 2 pi/3 and 4 pi/3. So this last one, we're solving an equation. We have a reference angle in the quadrants. On the final exam, you might not be called upon to do all of these things, but you will be called upon to do some of them. So in this case, we have the same procedure, just with one that we might not recognize, and that will change how we approach the last problem. But in this problem, we have suppose that sine of t is equal to -4/7. So that means sine or t is in quadrant 3 or quadrant 4. Because that is where sine is negative. Sine is negative in the third and fourth quadrants. Since we have that cosine is positive, we must be in quadrant 4. So cosine, that being positive means t is in quadrant 1 or quadrant 4. The only one that these two have in common is quadrant 4. So t is in quadrant 4. We have the same two strategies that we had before. We can build an angle, a right triangle in quadrant 4 using opposite and hypotenuse. So here's our angle T in quadrant 4. Opposite T is a -4 and hypotenuse is 7. Hypotenuse is a radius. It's a distance. It's always positive. Opposite and adjacent can be negative. In this case, we have opposite and hypotenuse. We just need to solve for the adjacent side. So the adjacent side is a square root of 7 squared minus a -4 squared. So that's 49 minus 16. So 33. So that's our adjacent side. So if I need to find the cosine of t, I'll have adjacent over hypotenuse. And it's going to be positive because we're in quadrant 4. Tangent of t, I will just use opposite over adjacent. Opposite is 4. Adjacent is the square root of 33. I'm not requiring that you rationalize your denominators on the final. So here is a right triangle style. In part C, now here we have the sine of t is equal to -4/7. So now we're looking for where the y coordinate is -4/7. So in this problem, we're looking for a y coordinate of -4/7. -4/7 is a little more than a half, so it's down here. The coordinates on the unit circle, we just got them from part B. Cosine of t is root 33 over 7. That's going to be the positive one in quadrant 4. Then the negative one in quadrant 3 will be a negative root 33 over 7. So I can list this, the x coordinate with a positive root 33 over 7 and a negative square root of 33 over 7. And both these points have a y coordinate of negative 4/7. Those are the two sets of coordinates that we are looking for. Just like in the last problem, we had an option. Instead of using the right triangle, we could use a trig identity, where we say cosine squared t plus sine squared t is equal to 1. We know that the sine is negative 4/7, and we could use that to solve for cosine. So 1 minus 16 over 49, that's where we're going to get the 33 over 49. Then when we do the square roots, we just leave the square root on the top of 33. The square root of 49 is 7. Now we make our decision, since cosine is positive, we choose positive. Where in part, this is the other version of part B, using identities. Then just like before for tangent, we just do sine over cosine. Sine is negative 4/7, and cosine is root 33 over 7. So this in blue would be also part B. The new thing for part D in this problem is that 4/7 is not one of the coordinates that we know on our unit circle. So this is not one that appears on the unit circle. So we have to use a calculator to find our reference angle. So our reference angle is going to be the sine inverse of 4/7. We don't worry about the negative. The negative is quadrant information, not reference angle information. So I'm just going to first make sure that I am in radian mode. And then I'm just going to calculate the sine inverse of 4/7. 0.608. We need to round to 3 significant figures. So 0.608. And we're going to put this reference angle into 2 quadrants. Sine is negative in quadrant 3 and quadrant 4. The angle in quadrant 3 will be pi plus the 0.608. And in quadrant 4, we go 2 pi minus 0.608. So if we look at our diagram up above, here's pi. I want to go pi plus 0.608. And here's the quadrant 4 angle. And here's 2 pi. I want 2 pi minus the 0.608. So our quadrant 3 angle is 3.75 because we want 3 significant digits. And 2 pi minus, I don't want to round off, is 5.67 to 3 significant figures. Don't worry about the sign when you're using your the sign positive or negative when you're using your calculator for the reference angle. Just the sign plus or minus tells you the quadrants that you're going to be, that you need to put the reference angle into. So here the problem, a similar problem coming at the unit circle from a different perspective. Here, we're going to consider the points on the unit circle with an x coordinate of 0.6. Consider the points on the unit circle with an x coordinate of 0.6. So if x is 0.6, so here's a half. So here's 0.6. That corresponds to 2 points. What we will want to do here is the usual thing. So if x is 0.6, the unit circle is x squared plus y squared is equal to 1. That's the identity that we want to use. We can also think of this as cosine of t is equal to 0.6, and cosine squared plus sine squared is equal to 1. So I'm just going to use this Pythagorean identity. So this is the equation for the unit circle, and my x coordinate is 0.6. The equation for the unit circle, x squared plus y squared equals 1, is the same as the Pythagorean identity. Cosine squared plus sine squared is equal to 1. X is the cosine, y is the sine. So now I've got a positive 0.8 and a negative 0.8. So there are the points on the unit circle with an x coordinate of 0.6. We can see that this gives us 2 angles, one in the first quadrant and one in the fourth quadrant. So in part B, if t corresponds to the point on the unit circle with an x coordinate of 0.6 and tangent of t is negative. So that is telling us what quadrant we are in. Tangent of t is negative is telling us that t is in quadrant 4, because tangent is negative in quadrant 4. Find the exact value of cosine t, sine t, and tangent of t. So the point that we're interested in is the point in the fourth quadrant. So cosine of t is the x coordinate of that point in the fourth quadrant. Sine is the y coordinate of that point in the fourth quadrant. And tangent is just sine over cosine. So sine is negative 0.8, cosine is 0.6. 8 over 6 is 4/3. Part C, we want to find the two. We want to solve the equation. We want to find the angles T that have an x coordinate of 0.6. There's one in quadrant 1 and another one in quadrant 4. So we're going to use our calculating machine for a reference angle, because when we look at our unit circle, we don't find anything with an x coordinate of 0.6. I got x coordinate of 0.5, and the next one is √2/2, which is like 0.7. So don't have the one in the middle. So we're going to use a machine to find our reference angle. We actually have three options for how we're going to find our reference angle. The given information is an x-coordinate of 0.6, so I could use that and say cosine inverse of 0.6. .927. But we also have the sine of t is negative 0.8. What if I did sine inverse of 0.8? Remember, we don't worry about the positive or negative. Still 0.927. But we also have tangent is negative 4/3. What if I did tangent inverse of 4/3? .927. So whatever the case, our reference angle is 0.927. And we're going to put the 0.927 in the first and fourth quadrants. Because those are the quadrants that have a positive x coordinate. So in quadrant 1, the angle is just 0.927. In quadrant 4, we'll do 2 pi minus 0.927. .36 to three significant figures. This is how we're playing the unit circle and the solving equations game. Page 4 of final exam practice part 2 is just the unit circle. There's no instructions here. It's just for reference. So this page, like I said earlier, will be provided for your reference on any parts of the final. Any questions? So here's parts 1 and 2 of the final exam review represent a sample of the kinds of problems I will be putting on the final exam. Remember that our final exam is on Thursday next week. It happens at 2 o'clock and runs till 4:40. So this starts an hour later than class normally starts. So the final exam will start 1 hour later than class. The usual test rules apply. Bring a calculator, bring something to write with, bring something to unwrite with, bring a beverage, a non-alcoholic beverage to stay hydrated, bring a caffeinated beverage to stay energized or focused, bring a tasty beverage if you just want some entertainment, At any point during the final exam, it is 2.5 hours long. At any point, if you need to get up and use the restroom, you have permission to get up and use the restroom. If you just want to go outside and get some fresh air, you can go outside and get some fresh air. If you would like to listen to music or a podcast or whatever, you can listen to audio. You cannot watch video during the final exam. The final exam will take place in this room. So as a normal, it'll just feel like a different meeting because it starts an hour later and runs till 4:40. So 2.5 hours rather than a normal class of 2 hours. Let's see. So there is no class on Tuesday, May 20th. Starting this Friday, the 16th, we are switching to final exam schedule. So there is no class next Tuesday. We do not have a class meeting next week on Tuesday because it's final exams and you have some other final exam to take at that time, depending on what your Tuesday, Thursday class schedule looks like. See. This week on Thursday, I am just going to be answering questions. So I will open up the Zoom meeting, but I will not, instead of being in this room, instead of coming to campus, you can just log into the Zoom meeting. But next week on Thursday, I will just be holding office hours in my office, which is 7324D. So instead of a class meeting in this room, 7104, I will just be up in my office to answer questions in 7324D. So Thursday, what's today? Tuesday, 15. So Tuesday the 13th. So 15 May of this year. There's going to be no class here in 7104 because we've completed going over the final exam review, both parts. I will have office hours in 7324D. That's from here, go 3 floors up, and it's in that corner of the building. This is optional. You do not have to come and ask me questions just to make it look like you have questions to ask, or just because I'm just going to be keeping track of who's showing up. If you have questions, that's where I will be. If you do not have questions, I will see you next week on Thursday for the final. One thing to keep in mind, if you don't show up for the final next week on Thursday, I will take that as your resignation from this class and that you'll just take this class some other time. If you email me after the fact, there's not really much I can do. On Friday, the 23rd, that's when I have to go back into my coffin, and there I stay for the rest of the summer. I don't come out until August. So if you send me an email on May 24th, say, oh, hey, can I make up the final? I will not be able to respond to that email until August because I will be in my coffin and I don't get Wi-Fi in the coffin. It's kind of a nice way to unplug. If I come out and answer an email, all of a sudden I catch fire. So it's like a whole thing. I'm just kidding. I'm not a vampire. All that vampire lore is just teacher lore. Teachers have to go in their coffins during the summer. Any questions? Comments? It's not that bad. I'll answer your emails. But there's not a lot we can do. Grades are due at a certain day, and if we don't take care of things by that day, you just get the grade that you're going to get. Any questions? Comments? Snide remark? If there's one thing that we could learn from Hall of Famer Cal Ripken Jr., is that the most important thing to do is show up. Even if you're not sure you can do anything, show up, see what you can do. That's going to do it for today. That's going to do it for this semester until the final. I will possibly see you on Thursday for office hours. I will definitely see you next Thursday for the final exam, but at 2 o'clock, not 1 o'clock. You can be here at 1 o'clock. I just won't be here. We'll just be hanging out in this room, maybe with some other class taking a final. I don't know. That's it for today. That's it for this week. That's it for this semester. I will see you at the final next week on Thursday. I will get this recording uploaded today. I had some issues with it, and so the other one didn't come up fast enough. This one I will get up today. All right, everybody. Thanks for playing.